Hey guys, today we're going to be looking at relations. This is an important topic for testing, any type of testing that you're going to take, whether it's SATs, HESPA, PARC, whatever test that they're going to come out with, it is for sure going to include relations. So a relation is it's a way to represent a set. It's a set of ordered pairs. So a relation is a set of ordered pairs, and it can be represented in so many different ways. All right. So the first one is it can be represented by a set of ordered pairs. So that's kind of like 3, 1. So the relation is my x is the domain. My x is 3. That's my domain, and it goes to my y, which is the range, which is 1. So it can be labeled as a ordered pair. It can be shown as a table. So we have ordered pair. We have a table. A table is if we had an XY table. So 3 would be my X and Y would be my 1. So that's a table. And then it could also be labeled as a graph. So we'll do that in red. A graph. So if I had an XY coordinate, right? 3. So I would go over to 3 in my X, 3, and 1 in my Y. And it would be right there. So that's as a graph. Or it can be labeled as a mapping. A mapping does this. So I'm still looking at my point 3, 1. A mapping says you have a box of X's and you have a Y box. And what you're going to do is inside, I'm going to put inside my X is 3. And inside my Y is 1. And you're going to draw a line that says 3 goes to 1. So it's a mapping. So if we're looking at this example here, we're going to express the relation 1, 1. It's a whole set of points. 1, 1, 0, 2, 3, -2. And we're going to do it as a table, a graph, and a mapping. So as a table, so this is already as a set of ordered pairs. So that's this one, set of ordered pairs. All right. If we're going to do it as a table, notice it's going to take all my X's and then it's going to put on my Y's. But so X, Y, X1, Y1. X1 was 1, Y1 was 1. So they put them together. X2, Y2. So it would be 0, 2. And then 3, -1, -2 would be X3, Y3. And 3, -2. So I can set it up as a table, which is what we did here. We set it up as a table as well. As a graph, so we did our table. I'll put a check through it. Now we're going to look at a graph. So a graph just means you're going to plot all those points. So 1, 1. That's right here. 1, 1. And then you have 0, 2. 0 up 2. So that's 0, 2. And then we have 3, -2. 1, 2, 3. 1, 2. Down 2. 3, -2. So this is a relation. It's all showing up. And then the mapping. Now what's cool about the mapping, you have your box. But notice the arrow. X was 1. Well, it went to Y is 1. X was 0. It went to Y is 2. X is 3. It goes to -2. So that's how you do these 3 different ways of representing the set for the relation. And then the next thing you're going to do is determine the domain and range. So domain is input. So input, or we also call these our independent variables. Independent. Independent. So that's our domain. Our range is output or dependent variable. Dependent. So our range depends on what we put in. And so usually our y depends on what our x is. We could put whatever x is, but y is going to be dependent on what x is. So in that case, another way to do this is our input is usually going to be our x variables, and our range is usually going to be our y variables. So if you look at this, our x variables, and they put it in order because when you do domain and range, you want to put it in order. So they're looking at our x variables. X was 1, 0, and 3. So they put it 0, 1, 3 because you put it in order. Our range is our output. Our y variables were 1, 2, and -2. So in order, that would be -2, 1, and 2. And so that's all you're doing today. You're going to do this problem. You're going to express this set, -2, -1, 3, 3, 4, 3, as a table, which will be here, as a graph, which would be here, and as a mapping, which is here. And then you're going to determine the domain and range. So you're doing exactly what we did here. So good luck, guys. Have a good day. Reach out if you need help, all right?